In this lesson, we're going to learn about factorizing the GCF from a polynomial. The GCF, or the greatest common factor of two numbers, and when we say two numbers, there are two whole numbers, is the largest number that divides both whole numbers evenly. This also applies to algebraic factors such as x to the n and x to the m, whose greatest common factor is x with the smaller exponent. For example, the GCF of x to the 4 and x squared is x squared, because x squared can evenly divide x to the 4 and itself, which is x squared. Let's look at the first example. We have a binomial, two terms, okay? Each term is called a monomial. Each monomial may have a coefficient, and it has the variable part, or the variable factor, I should say. And we're going to factor it out. Okay, so you're going to first look at 12 and 18, find their GCF. 12 and 18 have common factors such as 2, 3, 6, but 6 happens to be the greatest common factor. So we're going to write the GCF of 12 and 18 out. The GCF of x cubed and x squared is x squared. Remember, x with the smallest exponent. So the GCF of the whole thing is 6x squared. To factor it out, you simply are going to take each term and divide by the GCF. Okay, so let's start with 12. 12 divided by 6 leaves you with 2. For the first term, x cubed divided by x squared leaves you with x. Okay, and then for the second term, 18x squared divided by 6x squared. Well, 18 divided by 6 leaves you with a 3, and x squared divided by x squared leaves you with 1. 3 times 1 is just 3, so you can just leave it as is. Let's look at the next term. We have a trinomial. Here, the coefficients are 20, 10, and 30. Their GCF is 10. Again, 20, 10, 30 have another common factor such as 5, but that's not the largest. The largest is 10. And for the variable factors, x to the 4, x cubed, x squared, the GCF is x squared, x with the smallest exponent. So the GCF of this trinomial is 10x squared. To factor it out, we're going to simply divide every term by 10x squared. Okay, so 20 divided by 10 is going to leave you with a 2. We have x to the 4 divided by x squared. That leaves you with x squared. When you are dividing two exponentials, you can just subtract their exponents. X to the 4 divided by x squared, you can do 4 minus 2. That leaves you with exponent 2. That's one of the exponential properties. All right, next we have negative 10 divided by 10 leaves you with a negative 1. You don't have to write the 1. X cubed divided by x squared is going to leave you with just x. And then for the last term, we have 30 divided by 10 whose quotient is 3, and x squared divided by x squared, which is 1. And again, you don't have to write 1 because 3 times 1 is just 3. And this is the factorized form of our trinomial. Let's look at the third problem. We have another trinomial consisting of terms that have coefficients 15, 25, and 35. The GCF of these three numbers is 5. Can't think of another number, another larger number that can divide these numbers. And for the variable parts, we have x squared y, xy squared, and xy. For x, the GCF is going to be x with the smaller power. We have x squared x, x. Those x's have power 1. So the GCF of x squared x is x. And for y, y squared, and y, the GCF likewise is y. All right, so the GCF of the entire polynomial is 5 for the coefficients and xy for the variable factors. Now you're going to factor 5xy by dividing each term by 5xy. 15 divided by 5 is 3. We have x squared divided by x, that's x. And then we have y divided by y, which is 1. And again, you don't have to write 1. We have the next term, 25 divided by 5 is 5. And then we have x divided by x, that's a 1, so you don't have to write it out. We have y squared divided by y, that will leave you with just a y. And then lastly, we have negative 35 divided by 5. That is going to leave you with a negative 7. And for the variable factors, we have xy divided by itself xy, which is a 1. So 7 times 1 is just 7. And this is the factorized form. For the last problem, we have coefficients 18, 24, and 30. Their GCF. Okay, so let's try some common factors. 2 is a common factor. 3 is a common factor. But are they the largest? So just keep trying. 4 is not a factor of 18 or 30. 5 is not a factor of 18 and 24. And then we have 6, which is a factor of all. 6 can evenly divide 18, 24, and 30, and that happens to be the largest factor. We have the variable factors x cubed y squared, x squared y cubed, and x to the 4y. For the x's, the GCF is x with the smallest exponent, which in this case is 2. And for the y's, we have y squared, y cubed, y. So y is the GCF because it has the smallest exponent. All right. So the overall GCF of this polynomial is 6x squared y. To factor that out, again, divide every term by 6x squared y. Let's start with the coefficient of 18. 18 divided by 6 is 3. We have x cubed divided by x squared, that is x. And then we have y squared divided by y, that's y. So 3xy is the first term inside the parentheses. For the second term, we have negative 24 divided by 6, that is negative 4. And then we have x squared divided by x squared, which is 1. You don't have to write it down. We have y cubed divided by y, that's a y squared. And that takes care of the second term inside the parentheses. And lastly, we have 30x to the 4y. 30 divided by 6, that's a 5. We have here x to the 4 divided by x squared, that's x squared. And we have y divided by y, which is again 1. You don't have to write it down. And this is the factorized form of our polynomial, okay? So anytime you have to factorize a polynomial or even a non-polynomial, the very first thing that you need to do is look for the GCF before you take any further action or before using any more advanced methods.